So I think we're going to change tracks for a moment here and look at something else, because there's actually a little bug in the input system, and I'd kind of like to work on that as well. It's a little bit slow getting around at the moment, and I want to check the speeds there, possibly give it the possibility of sort of flying a little bit faster. And I'd also like for the movement when we're flying to actually follow the direction the camera is looking rather than just staying on a plane. So that's going to be interesting. We're going to give that a go. So input class over here is just keeping a track on what keys are down. So we want to look at the camera here. So problem right now is that depending on your key presses here, I calculate a motion here, which is delta time. Okay, delta is a number of milliseconds, if I'm not mistaken. Let's take a look at where we call the tick function here. So we camera tick. Delta is based on mscript and get now. Time to look up documentation. Mscripton get now. So get now is current time in milliseconds. So we're past a number of milliseconds since the last tick, and we're currently multiplying that by 0.005. So that means that we are moving at, I would say that's 500 millimeters per millisecond, so 5 meters per second, which is, well, whether that's on the fast or the slow side, I can't really say off the top of my head. I want 5 millimeters per millisecond in kilometers per hour. 18 kilometers per hour. That's pretty fast, but it feels slow. Anyways, one of the problems here is that if you move sideways, sideways down here, or while you're moving forward or up and down, you can actually move even faster, and we kind of like to normalize this. So what we're just going to do is that we're just going to we're going to do a little bit of work on this, and then we're going to do some basic, oh my god, I can't think right now. We're going to do a little bit of normalization on this so that you can only move at a certain speed, and then we're going to multiply that final vector with the size of the motion we want. But we also want to do a little bit more, because I'd like to have the Z motion here also modified by the current view or current direction we're facing. So right now what we're doing is we're sort of calculating a local Z and X motion, and then we transform that based on the camera's rotation in Y. What I'd also like to do is I'd like to modify that by the camera's rotation in X as well. And then once all of that is done, we add in the up-down motion from shift or space, which, by the way, at some point we're going to have to sort of factor out so that we can actually configure these keys, but some other time for that. Diagonal? Yeah, I was probably looking for a word diagonal. I've forgotten half my words by now. So when we're doing our camera view transform, we are looking at this stuff. So we're doing this oppositely. So our this is going to be fun. what I'm looking for, rotation around the y-axis is this thing. This is going to be a lot of fun because I can't tell exactly if I want A and D to influence this directly. Well, we're going to start with the normalization step. So all of this is just going to become 1 all of a sudden. So we just have this sort of like 1 unit motion. Great. Then we go for our motion vector. Motion, and then, okay. Can I do normalize? Documentation time again. GLM. OpenGL Mathematics Library. API documentation. And manual. There we go. So we have lots and lots of fun stuff here. Let's search for normal. There is a GLM normalize function, which sounds like a good plan. So what we'd like to do is we'd like to have motion be GLM normalize of motion times the delta. And I want to do it a little bit faster now, so we're going to go for 10 milliseconds per 10 millimeters per millisecond. Float. There we go. So that should normalize the motion vector. Get that done. Just quickly compile that. And switch over. Refresh. Okay, I do not like the part where this meant that nothing's happening now. Okay. Quick random thought. Motion may have length 0. And if it has length 0, we do an integer or floating point division by 0, which is probably bad. So we are going to have a Boolean moved, which is initially false. And if any motion at all occurs, we're going to set that to true. That way we can see that we have actually done some motion. And in case we actually have moved here, then we are going to do all of this stuff. That also saves us a little bit of computation. We can do the same up here. So only if we've moved at this point will we actually bother doing a transformation of that motion at all. Because that way, if you haven't been pressing WASD in any way, then we don't have to do all of this computation, which, though not terribly expensive, does involve some sine cosine stuff here, which is not terribly fun. Let's give that a go. Switch over and refresh. There we go. Slightly faster motion now. And we have it normalized along the various planes. The faster motion is actually really great. I mean, it's way too fast for use in the end game, but it's good for looking around here. And I can really tell that we have the normalization on now, because when I'm going upwards, it's really not going forward as fast. So that's great. Wonderful stuff. So yeah, that's the thing now. I could just fly around here for a couple of minutes. Great. So let's see if we can add the entirety of the motion transform. See what happens if we do that. So we're over here. Right now we're adding a little bit of motion transform. We're doing sort of the inverse rotation and adding that. So what I'm thinking should happen is that we should take all three here and add those in. But we're gonna, again, go for the negative versions of these. And I suspect we should also be doing it in reverse order. So we first apply Z, then Y, and then X. So let's see what happens. So compiled, let's switch over. So now my camera is nicely following the way I'm pointing it, and I can do really, really nice flybys here. That's great. That is what I wanted. Wonderful stuff. This is really great for like spectating or showing off terrain. So, I think what we're going to do now is that I am going to ask chat for suggestions as to what's the next thing to work on. Because while I'd like to do smooth terrain, I really need to do some research before that, because it requires doing something I've definitely never tried before. Something called singular value decomposition, which is basically nasty math to solve a matrix, or to do a least squares approximation of a matrix solution, which is fun. And I need to read up on how that works before I'm willing to do that on stream live. So if chat has any good suggestions for what might be fun to look at, I'll happily listen. And, well, basically, if chat doesn't come up with anything in like the next 10 minutes, I think we're going to end the stream here. So it's all on you, chat. In the meantime, I'm just going to fly around here. Oh, this looks interesting. I mean, on possible things we could do, it's possible we could try and get rid of these walls at the edge of chunks that are always there, which are pretty unnecessary. We might also consider doing stuff like working on introducing cave systems, would be another possibility. Though at the moment I don't really have. Fix the floaters or day-night cycle? Yeah, both possibilities. Floaters are a little bit interesting, especially if they're on chunk boundaries, because that means I have to look into the other chunk and see if there's something there. Well, at least that's the theory of it. I could ignore that entirely and say, nah, why the hell? But the problem is, especially if they're like on the lower edge of the float of the chunk, then I have to look at the chunk beneath it, and I might not have that generated. So that's a little bit nasty. Day-night cycle. Oh, that requires me to also look at lighting. Well, I could do ambient lighting pretty easily. Would be doable. It would require me to start maintaining time, knowing what time it is. I think day-night cycle is probably something that could be done quickly. Floaters, I think we can do at least stuff like this where you have a floater which has like nothing attached to it at all would be fine to get rid of. That we can definitely do. And then just sort of do the naive thing whenever we're at a chunk border and just say remove it. Bigger floaters like this, well, the thing is, something like this size I don't want, but I want the ability to generate large floating islands actually. Oh, I am so not doing lighting because, or shadows, because that is really, really shit to calculate. Okay, we're starting with like single block floaters, getting rid of those at least. So we're generating stuff here. So what we're just going to do is the really, really simple, naive version is that we are going to walk through every single block, and if there's nothing around it, then it's a floater, we remove it. That, at least, I should be able to do. So, we're looking at this. If, and then we need to look at stuff if x is 0, or the block next to us. Do I have like the, yeah, I have a get function. Or the block next to us at x minus 1, y, z here is 0. And so this is like if the x0 one is wrong, then we can, I want to split this over multiple lines, otherwise I am going to die slightly. Or if x is at size minus 1 or x plus 1 is 0. So if we're at either x chunk edge or the next one is air. And same goes for y. We're going to go down through this y, y, z. Oh my god, my editor is killing me. Z. And then we need z plus 1 here, minus 1, get rid of the x here, the x offset, y plus 1, y minus 1. So that gets us all of that. If that is always the case, then we are potentially a floater. Could do an early out at the beginning. I only want to check if this is a floater if I actually am a solid block. So if I myself am not 0 and all of this, then I want to set 0 at x, y, z. That should get rid of single block floaters. So we're linking. Go for it. Yeah, I'm not seeing single block floaters at least. Thing with the larger ones is you need to do proper connectivity, find out how big that floater potentially is. And I have no clue why my browser is currently doing that. And it's, oh, I hate the idea of actually going across chunk boundaries. At some point I'll need to, because I want to get rid of these things at some point. But it's really, really nasty figuring out if something is attached at a chunk border or not. So far so good. So let's think about this. So to determine a floater, what I'd like to do is basically I'd like to sort of count the number of attached blocks, and if it's below some threshold, we remove them all. So that means we would need to walk a structure like this in some order to figure out how many blocks are attached. And then the question also arises, what do we do when we hit a chunk boundary? Because now I'm walking. Right now I'm just assuming if it's on the other side of a chunk boundary, it's air. So remove it. That can be a wrong decision, but I mean, it's as long as the player doesn't notice it, it doesn't really matter. I mean, we can cheat and do pretty much whatever we want as long as the player doesn't notice. It's a wonderful thing about games. Like, it's definitely not impossible to do. It's just not really fun in any way. And it might, if we assume the same thing where we're saying, okay, the moment we cross a chunk boundary, then it's disconnected, or then it's just air. This might really ruin the tops of mountains because there might not be that much in a chunk on the top. I mean, we could risk that, like, these little 4 blocks here are the only thing in that chunk, and they would get removed, or maybe a little bit more than that. So there is this thing about counting and then fine-tuning a limit for that as well. Okay, well, let's try and at least count the number of blocks. So we're going to do a little bit of a helper function here. Because I really don't want to, we can do this in the generate. Chunks are, well, it says right here, 16 by 16 by 16. So that's potentially something like 4,000 blocks in a chunk? If I get my math, no, it's not 4,000. Yeah, it is 4,000. 4,096 blocks per chunk. Great, so we're gonna add a void kill floater, because that's a nice name, I like it. And we're gonna take X, Y, and Z coordinates that we want to kill a floater at. So what we're gonna do is that we are gonna have all of this fun stuff here. I want for my chunk, I have a kill floater function. We are going to move all of this stuff into that initially. There we go. And then we're just going to call kill floater with X, Y, and Z. So for this, if we're going to start counting, then first thing we want to do is we want to check, is this point already empty? Because if it's empty, it's definitely not a floater, and we're done already. That's the easy case. So if it's not the easy case, then we want to start counting. And what we are going to do is we are going to do a standard set of tuples. Actually, GLM IVEC3 might be better. So standard set of GLM IVEC3, 3. So 3D vectors. Yeah, I want to import that. And these are our blocks that we've seen. And what we're going to do is we are also going to have a standard queue of also IVEC3s here, which is going to be our open set. And for our open set, we are going to push in a 3D vector consisting of our x, y, and z coordinates. So as long as our open set is not empty, i.e. we have more vertices to discover, and the number of blocks that we have seen so far is below our floater limit, and we are going to define floater limit, const expression size t floater limit, as we're going to go for 16 initially. That might be a little bit high, but we'll see what it looks like. I mean, the important thing is what it looks like, not so much else. So while we're doing this, we are going to pull off a current position. So we get an auto current, which is from our open list. We take the front element here, and then I want to remove that front element. Hey, lunatic, don't be using the caps. I really hate the caps. Don't use it. Oh, not so much that you're not allowed to say hey, not more that you're not allowed to use that many caps. Anyways, so once we've done this, what we want to do is that we have our current list is, so we pulled a position off our queue. What we want to do at this point is that we want to take this current one and we want to add it to the to the blocks we've seen. So we insert this current one, and then for each of the neighbors we insert it. If we're at an edge, we kill it off and stop. You can always message me a link. Kind of prefer that as opposed to posting it in chat, but we can do something about it, something like that. And hopefully you can post a link now. And we're out of music, apparently, for today. Go ahead, throw it to me anywhere. Gonna go here.